Hello everyone, my name is Levi Starrett. Today I'm going to be talking to you about some work that I've been doing in Textual xtUML and specifying a language to represent Shlaer-Mellor. So I'm going to start off just by declaring my outline so you have an idea of where I'm going with this presentation and also my goal. So the first thing I'm going to do is explain some of the problems that we're facing in this community with Shlaer-Mellor and with xtUML specifically. I'll be giving a proposal for Textual xtUML as a solution to some of these problems. I will be describing a future ecosystem centered around this textual specification and also giving some ways that you can get involved and help move forward. So by the end of this presentation, I hope to convince you, as I've been convinced, of the importance of developing this shared standard of xtUML and cast some of the vision of the possibilities of the ecosystem and the community going forward. So starting out with a problem. In this year, 2022, an xtUML model is basically a BridgePoint model. There are ways that you can work on an xtUML model separately from BridgePoint. There's a tool called xtUML that allows you to use Python to load and generate code from a BridgePoint model. But for the most part, editing and manipulating and executing models, xtUML models, requires BridgePoint. The problem is BridgePoint is bloated, buggy, and outdated. It's painfully expensive to maintain and improve. Just this last month, I was performing the release of BridgePoint Pro, and I ran into a build chain issue that ended up taking 30 hours of my time to solve, and it wasn't adding any value. So it's very difficult and expensive sometimes to maintain BridgePoint. There are very few BridgePoint experts out there. Myself and a handful of other people are building BridgePoint, but for the most part, it's very difficult for developers to get involved. And even if one wanted to use a different tool to work on xtUML models, such as xtUML, they would need to have an intimate understanding of the meta model, and the meta model is only accessible through BridgePoint. That being said, out of the available public Shlaer-Mellor tools, BridgePoint is the only one that's being widely used by more than one team. BridgePoint is a monolith at the moment, so let's take a look at this. We have a bunch of good IP in here. We have the xtUML meta model, we have diagram and text editors, we have model compare, we have verifier. Many of these applications are themselves modeled and are good stuff. But the problem is they're trapped inside the platform, which is Eclipse. And not only that, but the platform is locked down by things like the custom code generation, MC Java, legacy code, build dependencies that can't be updated, and dead code. So again, it's very difficult to move BridgePoint forward. It's difficult to get developers in. So we have all this good stuff, but it's kind of trapped inside BridgePoint. Here's another problem. Even with modern version control technology, the persistence architecture as SQL insert statements of BridgePoint makes it very, very difficult to solve merge conflicts, even simple ones. When you're working tightly in a team, it usually requires either an expert to sort out merge conflicts or just to work in series. So here's some chat excerpts from me and a team that I've been working with this year concerning conflicts. I say that conflicts are not necessarily bad, but for our team, it's probably easier to work serially. Help, I'm having a Git nightmare. It should perform the automatic merge with no conflicts. Conflict. It passes all the tests. Hopefully there aren't any conflicts. After getting some merge conflicts resolved, I can move on. Great, I'm servicing the pull request. There are some conflicts. I know what I need to do, but I don't know how to do it. And here's some actual footage of Colin and Greg at their computers trying to solve these merge conflicts. And here's another problem. There seems to be a lack of clear and concise and correct documentation on the methodology and its implementations. I have to be careful here because the Shlaer-Mellor Commons is doing some good work in the past couple years to bring things into clarity, But a lot of what the work has been doing has been just adding to the pile of books and papers and documents out there, and not bringing it into very clear, concise, concrete documentation. I think of it this way. How often do I have a question in the community that I end up looking at BridgePoint source code or MASL compiler source code to answer the question? For example, I was discussing with John Wolf just the other day about OAL dynamically allocated arrays. And the OAL reference says that the arrays will be expanded if you access an element beyond the end of the array. But I knew for a fact that MC3020 has, for dynamically allocated arrays, the first time you access an element, that puts the static size for the array. So that was a situation where the architecture of MC3020 was not in compliance with the OAL handbook, and it was not documented anywhere. And for me, I knew about the implementation, and John knew about the OAL handbook. So this is my observation from that. Usually the most authoritative standard is the consensus of the implementations. What is verifier doing? What is the model compiler doing that I happen to be using at the time? And that's really the most important thing, because that's the code that's going to get generated for my application. But where does this consensus come from? At the moment, it's not coming from anywhere. It's very difficult to know if a model compiler is out of spec with Shlaer-Mellor or with the documentation in general. It's very difficult to know if model compilers are compatible with one another. It's very difficult to know if verifier is producing the same behavior as a model compiler, and all of those questions. Additionally, I think there's two ways we're shooting ourselves in the foot in the Shlaer-Mellor Commons community. First, I think that we're focusing too much on the historical Shlaer-Mellor. I also have to be careful here because I want to give respect to all that has gone before. But a lot has happened since the method was introduced, and we shouldn't be afraid of modifying and adapting to what's going on and what the needs are now. Also, we have this fear of being too implementation specific. We want to allow all of these different flavors of Shlaer-Mellor, which is good, but at the same time, it ends up becoming a confusing situation where there's no clear answers about anything. So we all have stories like this. My biggest issue in all of this is adoption and acceptance. I have sold xtUML to the stakeholders with the exception of the developers. There's a lot of concern among them, the biggest issues being the learning curve and questioning compilers. This was from a conversation in one of our xtUML chats. And I think it really is true, and I've had this exact same issue myself trying to get adoption of xtUML. There's a lack of clarity, a lack of concrete documentation, a lack of standard, basically. So what the community needs is a Shlaer-Mellor modeling language that's accessible. It removes those barriers to adoption. It reduces that cost of development, like we were talking about with BridgePoint being locked down, and it's viable long term. Of course, we want something that's going to last. So where do we go from here? Before I get to my proposal, I'll start with MASL. So MASL is a textual language that encodes all of the necessary structural semantics as well as activity semantics into a parsable, human-readable language. It can be serialized as text files, it can be viewed online, it can be viewed in an editor. And here's some pros for MASL. It's been time tested, it's been around for a long time, and it's been used in production for a long time. It also has existing tested back-end tools, the C++ code generator and software architecture, process inspector. If you want more information about this, see the footnotes and follow the link to see the MASL repository where all this is publicly available. Some downsides though, it lacks direct graphical tooling. So MASL is a pure textual language and it doesn't have any way to edit diagrams. We do have support for MASL through xtUML, but it needs to be edited within BridgePoint. Whoops, skipped a slide. The existing compiler and language specs are maintained behind closed doors as of right now in 2022. We do have the open source version, but the most recent version is still maintained behind closed doors. So here's my proposal. First, we need a language specification that would be defined to capture in detail the full description of the semantics of Shlaer-Mellor. This can be using MASL as a starting point. We have a lot of the work already done in MASL. There's additional things that we need to add to be compatible with all of the existing xtUML models, but MASL is a great starting point. And the goal with that would be that MASL languages would automatically be supported right out of the gate so that MASL modelers, the existing MASL tools and the existing body of MASL models would also work. An action language shall not be specified as part of the xtUML proposal, but a minimum set of capabilities should also be part of the spec. This would allow multiple action languages to coexist as long as they satisfied the minimum capabilities. Additionally, specifications for textual representation and graphical layout and the model of marking shall be defined. So we already have a prototype of the graphical layout language, and that's available today in BridgePoint. So let's go back to that monolithic design of BridgePoint and reimagine an ecosystem where we were using a textual language. So I'll get that out of there. So we start with the file system. We have our models as text files on the file system, and we're going to load those into what I'm calling xtUML tool domains. Here I have, for example, verifier, model analysis, model compiler, model edit, model compare, and many more. And the exchange for this interface is the textual language. Each of these components would be reading the file system, loading the instances into a meta model, and independently doing actions upon those model instances. At the top level, we have front-end platforms. So perhaps we have Eclipse plugins like we have today. Maybe we could have VS Code extensions, another very popular IDE. Or we could simply have a command line interface. And the exchange between the model domains and these platform domains is well known and well supported industry standard interfaces like debug adapter protocol, language server protocol, graphical language server platform, and JSON remote procedure call, and more. This way, we can distribute the load of developing these tools between different groups, different teams, separate them into different projects so that we don't have that monolithic system where all of that IP is locked up inside the platform and affected by all the platform choices that we have today. So zooming in on just one example here with the verifier. Inside this verifier application, we would have an xtUML persistence domain. This domain is what's responsible for parsing and serializing the instances, basically converting between the text specification and the meta model. This would be a fully modeled application and a standard implementation. We could build a reference implementation for this, and we could port it to different languages so that it can be reused in any of these modeled domains. The interface between the xtUML persistence layer and the model execution domain here for verifier would potentially be implicit bridging with counterparts, or it could be done with some sort of instance passing interface. The point is, this blue persistence domain component could be reused in any of these tooling applications and just paired with a different set of application logic that does something different with those instances. But all of them would have the ability right out of the box to load instances and serialize them back to text. So how does all of this solve our problems? Is it accessible? Yes. With a textual language, all you really need is a text editor. You can view the models online for code reviews in GitHub or other tools. You don't need to fire up BridgePoint to navigate your models. There's a cohesive open source specification and this toolchain ecosystem we've been describing. Low barrier to adoption? I think so. New modelers can jump right in and start learning xtUML without having to worry about learning a tool and dealing with tooling issues. Textual languages are very familiar to developers, and so therefore the graphical only with the very inscrutable persistence format would not be a barrier to adoption. Cost of development, the language no longer linked to BridgePoint. Other tools can be built in parallel, and as I described in the previous slide, we would distribute the IP of these different tooling domains into their own projects and applications so that if there's an issue with one or one needs to change something, it doesn't affect them all. Easy collaboration. Merge conflicts could be avoided, or merge conflicts could be easier handled with semantic text rather than instances being persisted to disk. Would it be scrutable to newcomers? I think so as well. They could find satisfying answers in the specification, and they would be able to find which tools were complying with which parts of the specification, and there would be a language for us to talk about what a specific tool supports and what it doesn't. And viable long-term. Model data in a human-readable state would not be tied to a tool. If the specification is well maintained, that model data could be taken and transformed into something else, even if the tools go away. So let's look at where we're going with all of this, the roadmap. Okay, it all starts with the language spec. Once version 1 is completed and reviewed, we can move on. Next, we can do an intermediate step where we update the BridgePoint persistence layer to start immediately using this textual language spec with the existing BridgePoint. We would need to do a refinement editing pass on the meta models to make sure that everything could be brought together. That's the MASL meta model, the graphics meta model, marking meta model, existing xtUML meta models. Once the spec and the meta models are refined, we can build that xtUML persistence domain reference implementation that can convert between the text and the meta model instances. We would need a legacy conversion tool that could go between the instance-based persistence format and the text-based persistence format, both for supporting older model compilers, as well as being able to load the newer models into the newer tools. Once we have that persistence domain completed, we can start working on those tooling domains. And first on the docket is a model compiler, Sierra and MC3020 being perfect candidates first. The remaining modules can be built using the model compiler, so they can be fully modeled using the new textual xtUML. And also, as those edit modules are completed, we can talk about platform decisions and integration into a target platform such as Eclipse or VS Code. Okay, priorities for these tools. They need to be implementing good domain separation. Model editing, code generation, model execution, etc., all in separate domains, as I showed in that previous slide with all the green bubbles. That way the important IP doesn't get entangled with each other or with the architectural or platform choices. They need to be fully modeled using xtUML. Anytime native code is absolutely required, it should be separated into its own subdomain or provided with a custom code generator plugin. But this allows these projects and these models to be reusable beyond just the editing platform. And interoperability. So taking a CLI first approach, That doesn't necessarily mean they are on the CLI or on the command line. It just means that they should be controlled via command passing rather than being tied intimately to a platform choice. So these modules can execute independently and communicate via these standard interfaces. This has callbacks to stuff like the Unix pipeline, and there's a reason why that works so well. It's because each application was a small, very focused chunk that had one job to do and that had an interface where you could chain them together to perform more complex operations. Similarly, model compilers, verifier, edit modules, all of that stuff could be brought together into a cohesive unit inside a platform like Eclipse or VS Code. Okay, so if you've liked anything that I've had to say today, I do have some ways that you can get involved and invest. First, you can review and comment on the specification. Again, see the footnotes. There's a link there to the existing specification that was written last December. You or your team can directly contribute to the roadmap items. Continued investment in MASL and its peripheral tools is always going to be appreciated, as MASL will be kind of the first infant stage of the xtUML spec. And also supporting BridgePoint, as BridgePoint will continue being the most available tool for the foreseeable future. Thank you very much.